Some teachers teach in a way where they are more dependent on you knowing reference angles. I do not. I am not a teacher who is dependent on reference angles to teach trig. So for my class, I will not be testing you on reference angles. That will not ever show up as a test question for me. But I want to teach you about them because I don't know if Miss Lopez uses them or not in pre-cal. Okay, so I don't want you to not know what they are. All right? Okay. So basically what a reference angle is it answers the question, how many degrees away from the x-axis are you? So if you draw an angle, how many degrees away are you from the x-axis when that angle is drawn? So if we look in the packet and we're on this question and they drew a negative 35-degree angle, and you answer the question, how many degrees away are you from the x-axis? Is 325 degrees away from the x-axis accurate? No. How many degrees away am I from the x-axis? 35. So the reference angle, because it's a distance away from the x-axis, it's always positive. It doesn't matter if you are underneath the x-axis or above the x-axis, it's always positive. It's also always a small angle because you're just going the fastest way to the x-axis. So if you are up here, you're going to measure it this way. You're just going to say, oh, I'm this many degrees away from the x-axis. If you're in the third quadrant, you're just going to measure it this way. Oh, I'm this many degrees away from the x-axis. So you are always answering the question, how many degrees away from the x-axis am I? That's what a reference angle is. So once you draw the picture, you just have to figure out how many degrees are standing between that angle and the x-axis. That's all you've got to do, okay? So 245 degrees, what quadrant would that be in? The third quadrant. So we're going to draw this. It's not quite to 270, it's a little bit past the middle, so it's right here. And so what we have to figure out is what is this part of the angle right here. That's what we want to know, is how many degrees are between this line and the x-axis. So from 180 to 245, how many degrees are there? 65. So the reference angle is 65 degrees. It is 65 degrees away from the x-axis. Negative 510 is going to be hard for me to think about because it's a very negative angle. So instead of using negative 510, I'm going to find a coterminal angle that is easier for me to wrap my brain around. So how could I find a coterminal angle? I could add 360. I could add 360 once, maybe twice, because it's negative 510 is pretty negative, right? It's more than one negative circle. So if I'm going to do negative 360 plus, or negative 510 plus 360, negative 150. Are you guys comfortable with negative 150, or do you want to add another circle? You added another? Okay. So 210. So negative 150 might be comfortable for you. Positive 210 might be better. So 210 is in what quadrant? Third, okay. So 210 is about over here. And so how many degrees are there right in here? There's 30 degrees in there, so we're 30 degrees away from the x-axis, so the reference angle is 30 degrees. Does that make sense? Same thing in radians. We're just putting our answers in radians because you always want the answer to match the problem. So with this one, we have 7 pi fourths. So I'm going to go ahead and draw this. We have 0, pi, pi halves, 3 pi halves. So over here, this would be where 4 fourths is, 8 fourths is over here. Is 7 fourths in the top half or the bottom half? It's in the bottom half, but barely in the bottom half, right? Because 7 fourths is really close to 8 fourths. Okay, so between 4 and 8, right in the middle of 4 and 8 is 6. 6 fourths would be right there in the middle. So 7 fourths would be right here. So this angle, there's 7 pi-fourths right there. So our reference angle is this part right here. That's the distance in an angle measurement, so not degrees this time, but radians. That's how many radians are from the angle to the x-axis. So how many fourths is that? 1. It's just 1. It's from 7/4 to 8/4. So we're going to say 1/4 pi. We're going to say pi-fourths is the reference angle because it was 1/4 away from the x-axis. Does that make sense? Now, this is, like I said, I'm not the type of math teacher to test you heavily on this because I don't really care about reference angles. I don't teach trig with reference angles. That is my personal preference as a math teacher. I'm showing them to you because I don't know what Miss Lopez does. She might use reference angles in pre-cal next year. Okay, that's why I'm showing it to you. So if you get into pre-cal, it won't be the first time you've seen it. Make sense? Okay. All right, so go ahead and put your packets from last night into the center. If you need to finish the reference angle problems, that is totally fine. You will probably have some time this period to do so. Okay, let's get out our notes from last night. We are going to finish up the notes. How did you feel about the unit circle stuff so far? There was a lot. You don't have to memorize it. I'm not going to make you do it again, but did it make sense as you were watching it? Okay. Did you guys remember the special right triangles from Math 2? 30, 60, 90? 45, 45, 90? Did you remember learning that in Math 2? Kind of? Okay. For the unit circle, you need 3 colors. I would recommend markers. It's going to be easiest with markers or highlighters. You need 3 different colors. You need 3 different colors. Yes. Yes, I do. I shall eat cookie. Oh, thank you. All right. It's yours. It's a gift. Yeah, you're welcome. All right. So, what we have to do next, we have all of the x and the y coordinates written. We have all of the degree measures written. So the next thing we have to fill in is the radian measurements, which means we have to do a little fraction review and just remember how fractions work again. So one of the things about the unit circle is that in Math 3, you get to have a unit circle in front of you, and then in pre-calc, you have to memorize it. So if you look at the unit circle, there's quite a few blanks in here. But if you guys notice, there were patterns for the blanks. Did you guys notice that? They were repetitive. So what I'm going to do is I'm going to show you how the radians work, because the radians are, I think, the hardest part of the unit circle. Okay, so I'm going to show you this is how you can memorize the radians. All right, so we're going to start with our first color. It doesn't matter what color you choose. We are going to take that color and we are going to go down the y-axis. And we are going to go down the x-axis. The x-axis and the y-axis. And for this, we can put the radian measurements that we already know. So we know this is 0 pi. And up here we have pi over 2, pi halves. And over here we have pi. And then over here we have 3 pi halves. And then over here we have 2 pi. All right. Now, when you do your fractions, the color you just did gets counted every time. And you'll see what I mean in a second, okay? It gets counted every time, okay? Because we're going to be counting fractions. All right, grab another color. This color is going to go on the diagonals, okay? So I'm going to do the 45 because that's where the diagonal is. So I'm going to do from the 45 to the 225. There's one diagonal. And then I'm going to do the 135 to the 315. There's the other diagonal. So if you look at what I did, the top of this is 1 whole pi, and you can see that I divided the 1 whole pi into fourths. Does everyone see that? The 1 whole pi is divided into fourths. Okay, so we are going to start counting in fourths. Are you ready? We've got 1/4. So I'm going to write pi fourths. We got 1/4. Do you guys agree that 2/4 is the same as pi halves? Okay. Then we've got 3/4. Do you agree that 4/4 is 1? Yeah, okay. Then we have 5/4. Do you agree that 6/4 is the same thing as 3/2? Yeah. Then we have 7/4. And then we have 8/4, and do you agree that that's 2? So we can check our answers. We've got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Does that match all your fractions? Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, now we're going to switch colors. Okay, with this one, we're going to ignore the color we just did. But we're still going to count, for me it's the green, I'm still going to count the green, but I'm going to ignore the pink. Okay, I'm still going to count the green, but I'm going to ignore the pink. So now I'm going to do all the remaining lines. So I'm going to do this line right here, and I'm going to do this line right here. I'm keeping the green. I'm going to do this line right here. I'm ignoring the pink. This line right here, keeping the green. This line, ignoring the pink. So I'm doing all the remaining lines, but I'm pretending that the pink is not there. So if I pretend not to see the pink, how many sections did I divide it into? 6. See, so 1, 2, 3, 4, 5, 6. You see the 6 sections? Okay, so what are we counting this time? 6. Okay. So I have 1/6. And then I've got 2/6, but I'm not going to write 2/6 because that can be simplified. What should I write? 1/3, okay. And then I've got 3/6. Would you agree that that's 1/2? Okay. And then I've got 4/6, but I'm not going to write that. 2/3, okay. And then I have 5/6. We agree with that? 5/6. Okay. And then I have 6/6. Do you agree with that? That that's 1? Okay. And then I have 7/6. And then I have 8/6, but I shouldn't write that down. What should I write? 4/3. And then I have 9/6, but what should that have been instead? 9/6. 3/2. 3/2, which is what it is. And then I have 10/6, which is 5/3. And then I have 11/6, which is what it sounds like, 11/6. And then I have 12/6, which is 2. Okay, so now we can count and just make sure we got it. We got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So with the radians, we don't have to memorize them, we can count them out. Does that make sense? Because they're fractions, we just count out the fractions. Does that make sense? Okay, so you do not have to memorize the unit circle this year, but if you want to, I will give you an extra credit opportunity where we can sit down, I will give you a blank unit circle and let you fill it out, and I will grade it for extra credit and give you a freebie quiz grade, okay? You can do it, you just have to tell me ahead of time when you want to do it, and I will let you guys do it during lunch. It just has to be done before the test day. Actually, I won't say it has to be done during the test day. I'll say you can do it anytime before the EOC. The EOC is the 20th of May. So you can do it anytime before the 20th of May, and I'll put a free quiz grade in. Okay? Oh, this test? I don't know. You'll have to look on Canvas. So there are 66 blanks, and so I just give you a score out of 66 and then figure out what percentage it is. Yeah. All right. So there are a lot of strategies for memorizing this. If you Google it, you'll see different strategies. The strategy that I use is exactly what I just showed you guys with the radians. With the degrees, I kind of count out the degrees. The degrees to me kind of make sense because it's 30 to 45. I just kind of count those out. With the 1, 2, and 3, I think about it's over a lot, so it's over 3. It's over a lot, up a little bit, so it's over 3, up the 1. And then these are the same, so it's over and up the exact same amount. So I think over a lot, up a little bit, over a little bit, up a lot. That's how I remember those, by the size of the numbers. So that's how I do it, but there's a lot, if you Google how to memorize the unit circle, there's a lot of like gimmicky shortcuts that people have come up with, like using your hands, the size of your fingers to help you remember, all sorts of weird things. You can come up with all sorts of funky things to help you memorize the unit circle, but if you want to memorize it and fill it out, I will give you a score, a quiz grade for that, if you want to try it. All right. Everybody got their unit circle in front of them? Okay, so now we're going to finish our notes because we want to know, like, why do we even care? What does the unit circle matter? Okay, so put the notes back in front of you. Okay, and what I'm going to do is through this, you guys can kind of see there's a circle, so I'm just going to go ahead and kind of trace this circle because I should have printed another one on this side of the page for you guys. So I'm just kind of drawing like the exact same drawings that I did in the video last night. But I sketched most of that through the paper. And we're just going to put a theta here. We're not going to say what angle it is. We're just going to say it's theta. And if it's a unit circle, what's the hypotenuse? 1. And then if we have the point xy up here, then that means that this side of the triangle has a length of x. That would correspond to the x-coordinate. And then this side of the triangle would correspond to the y-coordinate, because you go over to the right and up to get to the point. So what is the name of the one? Hypotenuse. What is the name of the x? Adjacent. What is the name of the y? Opposite. Okay. So if we wanted to know what sine of theta was, it's opposite over hypotenuse, which for this picture is what? Y over 1. And anything divided by 1 is, yeah, it's just going to be y. It's just going to be itself, right? Okay. So on the unit circle, sine of the angle is just the y-coordinate. So if I didn't have a calculator handy, sine of 30 degrees is 1/2. Sine of pi 6 radians is 1/2. I'll prove it to you. Let me see what my calculator's in. My calculator's in degrees, so sine of 30 degrees is 1/2. That's how the unit circle works, okay? And I can check that with any of these. Sine of 135 degrees is root 2 over 2. So it's that decimal, which is the same as root 2 over 2. Does that make sense? So that's what we're doing, and it works because of the triangles and because of how we drew the unit circle. So it's going to work every time, okay? All right, so let's look at the next part. Now, cos is adjacent over hypotenuse, so what should we be writing? X over 1, adjacent over hypotenuse is x over 1, but x divided by 1 is just x. And so the cos is going to just be the x-coordinate. So if we look at our unit circle and we say, okay, cos of 180 degrees, I can get my calculator out and type cos of 180 degrees, or I can look at my unit circle. Cos of 180 degrees is just going to be -1. It's going to be the x-coordinate. So let me do that real fast. Cos of 180 degrees, oh, that's -1. Does that make sense? Okay, tangent gets a little bit weird. Tangent is opposite over adjacent, which is what? Y over x, and we just learned that y is actually sine, and x is actually cos. So tangent is actually the same as sine over cos. So in the unit circle, we just learned that the x-coordinate corresponds to cos of the angle, and y corresponds to sine of the angle, and that is a big deal. We just learned something that is a big deal in trigonometry. So we're going to take that, we're going to write it on our unit circle because we want to have that information. So take your unit circle and write it anywhere you want. It doesn't matter where you write it. I'm going to write cos theta, comma, sine theta. That's how I like to write it, but you can write it any way you want to write it. I'm also going to write that tan theta equals y divided by x. I'm also going to write tan theta equals sine theta over cos theta. Write that as well. All right, time for some example problems. So leave your unit circle in front of you. We're going to write example problems in this space down here. So we're going to say evaluate without a calculator. 1. Cos of 7 pi fourths. So what you're going to do is you're going to look on your unit circle, you're going to find 7 pi fourths, and then because it is cos, are you going to look at the x-coordinate or the y-coordinate? X-coordinate, and the x-coordinate is the answer. So what is the answer? Root 2 over 2. That's all you got to do. Number 2. We're going to do sine of 270 degrees. Sine of 270 degrees. So find 270 degrees. Are you looking at the x-coordinate or the y-coordinate? The y-coordinate. And the y-coordinate is -1, so the answer is -1. Okay. All right. Next, we're going to do cos of 5 pi over 6. Cos of 5 pi over 6. Marvelous. Good. You're good. You're good. -√3 over 2. Okay. Let's do sine of pi thirds. So locate the pi thirds. Look at which coordinate should you look at? Look at the y-coordinate. What do you get? √3 over 2. All right, now we're going to do a tangent problem, and these typically require showing work. Okay, because you have y divided by x, which means in most cases you have a fraction divided by a fraction. There will be a point, because there's only so many problems. Did you guys notice that? We have redundant answers. So once you do a few of these, you'll be like, okay, I've shown work on tangent a few different times. Now I don't have to show work on tangent anymore because I've gotten all the possible answers there are to get. And now I just know what the answers are. Does that make sense? Okay, so we're going to do a couple of them together so you can kind of see what the possible answers are. And then once we do a couple together, you'll be like, okay, now the worst of it is over. I've seen what the answers can be. Okay? All right, so the first one, we're going to do tangent of 225 degrees. Tangent of 225 degrees. So tell me, what two things should I be dividing? Okay, now we already know the answer to this, right? We don't really have to do much work. What's the answer to this? 1, because you're dividing the same thing by itself. Okay, but I'm going to go through the process to show you what we should be doing anyway. So when you have a fraction divided by a fraction, what do you have to do? Keep it, change it, flip it, right? Keep the top the same, change it to a multiplication problem, and flip the bottom up. So we got -√2 over 2 times 2 over -√2. And then what happens is the 2's cancel, the denominators cancel. And then in this situation, the negatives happen to cancel, the numerators happen to cancel, everything cancels, we just get 1. All right, let's do another tangent problem. So this time we're going to do tangent of 2 pi thirds. Tangent of 2 pi thirds. What 2 fractions are we dividing? Which one goes on top? Not for 2 pi thirds. Square root 3 over 2 is the y coordinate. That goes on top. And then on the bottom, we have negative 1/2. Okay? So now I'm going to do keep it, change it, flip it. And I have root 3 over 2 times 2 over negative 1. So I end up with my denominators canceling. And I get root 3 over negative 1. And what is root 3 over negative 1? Negative root 3. Okay, let's do another tangent. This time we're going to do tangent of 30 degrees. What are we dividing here? Okay, 1/2 divided by root 3 over 2. So we're going to do keep it, change it, flip it. 1/2 times 2 over root 3. What happens with the 2's? They cancel. And we get 1 over root 3. Are we allowed to have an answer that is 1 over root 3? No, we are not. So I'm going to take my answer of 1 over root 3 and I'm going to fix it. And how am I going to fix it? Root 3 over root 3, which is root 3 over root 3 squared. Which is root 3 over 3. Okay? Last tangent question that we're going to do, tangent of 90 degrees. Tangent of 90 degrees. What are we dividing? 1 over 0. Can 1 be divided by 0? No, so what answer is that? What do we say? Say it again. It gets killed. No solution, or we say undefined. No solution, or we say undefined. Okay, I'm actually going to make you do one more because there's one more situation. Last one. This is truly the last one. We're going to do tan of pi. Tan of pi. 0 over negative 1. Can you take 0 and divide it by negative 1? Yes, you get 0. That's an actual answer. Okay. What I've done is I have made it so we have done pretty much every single combination. The signs are off. The pluses and minuses could be different, but these are, you've done the worst of tangent. You've seen all the different versions of tangent, okay? So sine and cosine are nice because you just look at it and the answer is what's written on the page. Tangent, you have to show your work, you have to like do some work, but we've seen the different scenarios that can happen. Does that make sense? We've seen them all. Okay, I showed all of them to you in these examples. So you can have 1 over 0, 0 over 1. You can have where they're the same on top of each other, or we can have the 1/2 and the root 3 over 2, and we can have the root 3 over 2 on the top or on the bottom. The root 3 over 2 on the bottom is the difficult situation. That's the one that most people don't like. Okay, so you guys, at this point, you have seen it all. So keep this out when you're working on your assignment, because that's about as hard as it gets. So I'm going to go ahead and pass out the worksheet I want you to do. This packet is basically asking you to look at the packet and look at your unit circle and not use a calculator most of the time. Just look back and forth, back and forth, back and forth. There's a lot of questions, but for the most part, you are looking at your unit circle, and the problems are not like, they're not going to take you 5 minutes. They're going to take you like 30 seconds apiece. Does that make sense? Okay. So let me get that handed out. All right, let's go ahead and try one of these together, just so you guys do not feel confused. I just want to make sure that you understand all of the instructions. So we've got 45 degrees. How many radians is 45 degrees? Pi over 4, okay. And then what's the x and y coordinate there? Okay, root 2 over 2, root 2 over 2. What quadrant is it in? Quadrant 1. Okay. So sine of 45, or sine of pi fourths, is what? So that's the y coordinate. Cos of 45, or cos of pi fourths, is what? Root 2 over 2, that's the x coordinate. And then tangent of 45, or tangent of pi fourths, is what? 1, yeah, because it's root 2 over 2 divided by root 2 over 2, and we know that when you take the same thing and divide it by itself, you get 1. Okay. How do you guys feel about that? Make sense? Okay. Let's go down to the next section. It says find the exact value for each of the following. Anytime they say exact value, they mean use your unit circle. Use your unit circle. No calculator. Your calculator will typically give you a decimal answer for problems. So the only way to get answers that are perfect is to use a unit circle. Okay. So let's try some of these. Sine of 240. Sine of 240. 4 pi over 3 is the spot, the 240. So sine is the y coordinate, which is negative root 3 over 2. Okay. Cos of 135. Cos of 135, negative root 2 over 2. Oops. Look at number 15. We have a negative angle there. So negative 150, that's the same as what? 210, yeah. So if you look here, you can see that if you measure it positively, positive 150 is right here. So negative 150 would be right here, so it's 210. Okay, so if we did sine of negative 150, that would be sine of positive 210, and so that's negative 1/2. Okay. Now, number 14 is real weird because they said cosecant, and we did not talk at all about cosecant. Anybody have any ideas? This would be a really good, like, bonus question. Okay, so if it's the opposite of sine, we're going to go to 30. Wait. It's the opposite of sine, so sine is the y-coordinate, so we're going to take the y-coordinate, and what are we going to do with it? 2 over 1, which is just 2. So if you were to see a cosecant, and you'll notice there's not a ton of them on here, so I'm not trying to like mess with your brains a lot, but if you see a cosecant or a secant or a cotangent, you just find the one that it corresponds to and you just flip it. That's all you got to do. So you still locate the angle like you normally would. You still look at the x or the y coordinate like you normally would. You just have to flip the fraction. Okay. All right, now the next one says to find the approximate value for each of the following, to write your answers to the nearest thousandth. This one is definitely asking for decimals. So if they're asking for decimals, what should we probably be doing? These are calculator questions. So anytime you're using a calculator, you are touching the sine, cosine, or tangent button, what do you have to be careful of? Yeah, degree or radian mode. Okay, so your mode is important on these. You have to be careful of your mode. So what mode should you be in on 23? Degree mode, you can tell because there's a bubble there. What mode should you be on number 27? Radian, you can tell because there's no bubble. So bubble, degrees. No bubble, radians. Okay, what mode should you be in on number 29? Radians, there's no bubble. It doesn't matter that there's no pi. There's no bubble, therefore it's radians. Does that make sense? Okay, so we'll make sure that when we do these ones, we can type it into the calculator, but since we're touching the tangent, sine, or cosine buttons, we have to be in the correct mode. All right, and then I think the rest of the packet, yeah. It's basically, I'm just forcing you to stare at the unit circle a bunch. That's all it is. I'm forcing you to get more familiar with it and get better at it, because a lot of this is an introduction to trig, and it's just making sure that when you go on to pre-cal, you're not scared of it. We're building our trig competency. That's the goal. Alrighty, go ahead and get working.